All right, we're back. We're on page 11 of notes 4 of Calc C, and we're going to do some practice problems. So we're going to run into a situation here, maybe potentially, where like we might not know enough yet to figure out if something converges or diverges, in which case we'll just say like we need to do more work. So let's see. First one is, if you rewrite it, it's pretty recognizable as a geometric series. Let's do that. So R is 1 over E, which is definitely less than 1. So the sum is going to be the first term. So you take 0 and you plug it in here for every n that you see. So you get 2 over 1 over 1 minus E. So that's 2E over E minus 1, I guess. So this one is kind of interesting because I think there's a number of ways that you can do it. So one of them is to look at this and be like, well, this is the sum of, so provided both of these exist, we can just do this. If they don't both exist, then you can't do it. It's just like with limits. You like try to do it, and if it works, it works, and if it doesn't, and then you don't do it. So this is, I'm gonna rearrange this a little. 1 over e to the n minus, so this thing here is e to the n times e. So I'm going to take 1 over e out, 1 over e, and then have 0 to infinity of 1 over e to the n, which again, I'm going to take, so basically what I'm doing is I'm factoring the sum from 0 to infinity of 1 over e to the n out of everything. It's going to leave me with 1 minus 1 over e. So I'm going to write that, maybe I'll like show that step. So I'm taking this out of both things, and that leaves me with 1 from the first thing, and then minus 1 over e. And then I just found this, right? Well, I sort of found this. This, if you just get rid of this constant multiple, is the same series. So it's e over e minus 1. So this will be e over e minus 1 times 1 minus 1 over e. I think that's how I would do that problem. I don't know. It's pretty nice. You could do them just separately, just do the two sums and then like walk off. Up to you. Nth term test for sure. So like you're always kind of thinking like, and you just get used to it, but you're always thinking like, is this geometric? Can I use the nth term test? Does this thing telescope? Like you kind of like run through it. Is it just straight up the harmonic series? Like who knows? But this limit, so it doesn't really matter that it alternates because this does not exist, right? Because eventually you're just alternating infinity, negative infinity, infinity, negative infinity. It doesn't exist. So since the limit as n approaches infinity of -1 to the n plus 1, n cubed over n squared plus 1, not 0, the sum, it's a lot of writing. It's very annoying. Diverges. So doesn't have a finite sum. All right, what can we do here? This is just two geometrics that both have a finite sum, so I'm just going to do each of them separately. So this is going to equal, so I'm just going to do them, right? It's first over 1 minus the ratio. So this comes from this part, and then plus the first over 1 minus the ratio. And this comes from this part. So there we go. So you can just do them separately. I guess you could get an answer here if you wanted to. So what is this? This is 2/3, so 3, and then plus 2, 5. Interesting. Is that right? 2/3, so 3/2 times 2 is 3, and then 1/2. Yeah, I think so. Interesting. All right, so this one, don't get fooled. This is geometric. It definitely converges. So this is geometric with, so R is actually, so what's being raised to the n? R is actually -1/3. The absolute value of R is less than 1, therefore converges. So how did I know that? I rewrote this kind of in my head, well, definitely in my head, I guess, as -4, and then -1/3 to the n. Which, like, you could leave the -4 inside or take it out. It doesn't really matter. Where's the -4 coming from? It comes from the fact that -1 to the n plus 1 is -1 to the n times -1, and then 4. So -1 times 4 gave me this. And then I have -1 to the n and 3 to the n, -1/3 to the n. So you can handle that however you want. I think that's kind of the easiest way to do it. All right, first term, plug in 0, you get 1. So times -4, -4 over 1 minus -1/3, which is 4/3, so -3, I think. We could check like pretty much all of these on the calculator if we wanted to. I don't know if I do, but we can. All right, this one, how many problems are on this page? I think I'm gonna do this one and then, no, you know what? I'm gonna check these on the calculator, then cut the video, come back and finish the page. I'm gonna do that instead. So let's see. Let's see what the calculator can and cannot do for us on these problems. Also, I don't think the mic is picking it up, but man, my computer is like not dealing well with the heat today. We're going from 0 to infinity of 2 times e to the -n. Give me an answer. 2, yes, got it. So the next one, we were doing from 0 to infinity. Uh-oh, gotta spell infinity right if you're gonna spell it. I-N-F-I-N-I-T-Y. Infinity, e to the -n. Get out of the way, cursor. And then minus e to the, I'm gonna write -n minus 1, I guess. Just straight up 1. Straight up 1, that's really interesting. I think, well, maybe if I'd done more work, I would have noticed that. I did not. I kind of like, I kind of quit on this problem as soon as I got something usable. We got this times this. 1, yeah, ooh, that's weird. For the next one, we did the limit of -1 to the n plus 1 n cubed over n squared plus 1 as n goes to infinity. And we got doesn't exist. And so, ooh, okay, let's take this out. And we'll just know that it's like all, so this gives me infinity, but when the -1 to the n plus 1 is there, we're bouncing infinity, negative infinity. So this definitely diverges. And then our next one is the sum from, well, k goes from 0 to infinity of 2 over 3 to the k plus 1 over 2 to the k. And 5 is what we got. And then, so this is, like, you should check your answers. I mean, I guess it turns out I check my answers all the time because in the videos, I'm constantly saying, like, I'm only doing this to show you that you should check your answers, but then I'm the one that's always doing it. Ooh, that came out weird. That's 4 over, there's always like, I never know where it's gonna, when I decide to like make a fraction, I never know where it's gonna put things. So -3, yes. All right, so we got all of them, and the calculator can check them, and you should definitely make use of that, including if you're like in college watching this and you're not allowed to use calculator on like tests or whatever. Doesn't mean you can't use it while you're doing your work to get a better sense of if you understand what you're doing. So I definitely always recommend that. All right, I'll be back in the next video to finish this page, and I will see you there.